All right, thank you. So my name is Tim Mangan. I'm from Team Merchant Technologies. This session that I'm going to do here is the first of the 3 lightning rounds. I love these lightning rounds because they're nice, fast, compressed. We can get a lot of stuff in a very short period of time. So the session that I'm doing is sort of based on a session that I did about, I think it was about 5 years ago, out at the BriForum in Darmstadt, Germany. That was called The Data Problem. And at that time, I wrote about how, and a white paper went with it, talked about how the things that we were doing with data didn't make a lot of sense to me. And in particular, as virtualization was now starting to come into play, the problems were going to get worse if we didn't do something about it. And I proposed some things at that point. And I'll show a little bit of that as part of this. But the purpose of the session here was to kind of do an update on where my current thinking is on data. This came out of some conversations that I've been having with people in this last year. And then a session that I was in up at the Synergy show out in San Francisco, where I got pulled up on a cloud panel along with Simon Crosby and Doug Brown and I think Steve Greenberg and Joe Schonk were up there as well. And I made a statement in there, and it drew a lot of response from people at the time. So I thought maybe I ought to flush that thing out a little bit. And so that's what we're doing here. And I'm going to introduce a new term I call the dataverse, which is really my idea of having a set of data and all of the things around it that affect it. And that's kind of the dataverse. We're like a universe, right? And we can have multiple of those. So why am I talking about this? Everyone thinks of me as being kind of the app guy, right? Because I do all this stuff with AppV and applications. And for the last dozen years, I've really kind of sat myself in between the layer between applications and the operating system, trying to figure out what these stupid apps are doing and then what is the operating system doing along with them. But we also have to think about data. Because every time I hear someone tell me that, what they're doing in IT, it's all about getting these applications out to users so that they can do productive work, I always say, no, it's not about the apps. It's really about the data. The apps is the thing that we see. It's the thing right in front of our eye. But it's really the data behind the scenes that's truly important. So, how many people in the room here at this point have an Apple product with them right now? We have, okay, so we got a good amount of Apple fanboys. So hold on to your socks. I'm going to make a claim here on stage for the first time that you're not going to like if you're an Apple fanboy. And that's because I ran the world's first app store. Okay? It was 1999, 2000. The company was called Software Wow, small startup in Boston that I joined. And we really had what you would call today an app store. We had server farms that were up on the internet, public facing. People could come in and they could browse, do self-service, and choose applications, mostly games. They could say, hey, you got the new Frogger there. I want that. And they would click on it. And we'd stream it down, and it could then just run on their local device. And that was our business. Now, what we didn't have in the way of an app store that we needed was a way to make any money at that, right? So that's why Software Wow kind of went away, and we transformed ourselves to Softricity. We built that whole application virtualization stuff as a result. But I ran the first app store, so that's my claim. All right, so let's talk about data, because I do say it's all about the data. Everything that we do in computing ultimately is so that end users can create and manipulate and consume data. The applications are merely the tools that they use to access it. And you can change out my application. That's fine. But it's the data that's truly important. That's what I want to make sure I carry over. So that's really why that seems to be important to me. So last year, up on brianmadden.com, I wrote an article talking about the different data models and that I saw going out there. And this is a picture of one of the data models. In fact, I think it was the first one in that article. And I called it the blob, okay? Because this is the typical data on your PC today. This is the way that data is organized. It's not really organized very well at all. There are clumps of stuff that kind of go together. But, you know, we've got some operating system here, we've got some applications, and sometimes they kind of intertwine there a little bit. You know, the application you bring in changes out some of the OS DLLs that are on there, for example. And we've got user data, and we got company data, and we're not really sure. It's really hard to look at my hard drive here and figure out where any of that stuff actually is, or for any particular file I happen to find, which of those categories would it really fit in? And this is part of the problem. What I want to be able to do is have tools that understand those things so that we can automate the processes. We can also secure our data. So now this is the model that all of the vendors that are out in that exhibit hall out there want you to see. Right? This is what they're going to sell you. They've got these great models, and they can do layering of stuff, and we can isolate stuff out, and it all looks nice and pretty in here. But that's what my PC still looks like, right? We don't really have that true kind of clean layering modeling that everyone wants us to think that we're doing with these products. There's still a lot of stuff that's just kind of thrown around, and we're hoping we get the right things in these layers. Okay. So in the presentation I did in Darmstadt, this was kind of the money slide of that whole thing, where I took an attempt at trying to organize data. I said, we need to come up with a model to organize the data. And I said, I'm not sure exactly what the model is, but here's an example of the kind of thing I'm thinking of. I want to be able to segregate out data by its different types. I want to know if some data is associated with a particular application or not. I want to know, is it company data or is it user data? Okay, personalization or personal data that the user has put on that machine. So I was thinking about scenarios at that point of things like, okay, so I want to replace out an application with a different one. Well, what should stay and what should go away? Or I want to replace this user's PC and give them a whole new OS with new applications. What should come along and what should stay and be thrown away? Not stay, but thrown away. Or let's say that user leaves the company and I replace them with someone else to do that same job. Which of the files that person was using are really related to the company and that job function and need to be given to the new person so that they can finish that work that they were working on, and what should be thrown away because it was, you know, the guy's personal photographs, let's say, right? So, so this is what I had proposed. We need to come up with a way to divide these things up and get the data organized on the machines. Then we'll be able to have tools that can automate those kinds of transactions for us automatically. Now, when I proposed that, I got a lot of people shaking their heads and saying, yeah, it's okay, we should do that. And in fact, I had some vendors that were at the show that came up to me afterward and said, wow, you know, we've been thinking about this problem. You are exactly right on. And in fact, we're going to be releasing a product within the next 3 months that's going to solve that problem for you. Yay! Anybody notice that problem getting solved yet? No. My PC still has the blob. Okay? We really have not progressed. What we have done, though, is we're at another point where the problem starts to get worse than it was before. Okay? I was worried 5 years ago about all of the virtualization that we were doing with the virtual machines and exploding the amount of data that we're leaving laying around in all sorts of dark corners of our company. But now we're moving in yet other directions, which is this one, right? We've got the cloud. So now we got more places to put our junk. You know, it's not just on my laptop. And the cloud ultimately consists of, again, applications and data are the things that we're using up there. I'm going to add a third category in there, rules, though, because rules become very important in my current thinking. We have rules about accessing the data. You know, since it's no longer on our personal device, we have to worry about those things. And fortunately, it's not just one cloud either, right? The rules that we're talking about are very specific to each of these cloud vendors. When you sign up for their service, you agree to some type of terms of service, and they have privacy agreements and all of that stuff, right? But each one of these writes it themselves independently, right? This is an infograph that is probably at this point maybe a couple of years old. I think if we tried to draw another one today, I'd need like, you know, a monitor the size of this wall to be able to actually show all of the different cloud providers that are out there. But they each have their own rules, and those rules ultimately aren't written for your benefit, okay? They're written by the lawyer of the cloud provider to ensure that should they screw up, you can't sue them, right? I mean, that's the real purpose of those rules. So if we try to model out, you know, what we're thinking about in terms of these clouds, this is kind of where I was starting with. You know, I've got me, and I've got these cloud providers out there, and I build these linkages to them, and each of these have these rules that are associated with them. And that's all well and good, except I started noticing that there were other things going on here, right? So I get these rule sets, and first of all, the rule sets can change on me on the fly. I can't negotiate them. They're just dictated to me. This is what it is. If you don't like it, use someone else's cloud, right? The second thing is that I can have one of these services can notice, ooh, you're on Facebook, or ooh, you're on LinkedIn, or ooh, you're on Twitter. Would you like us to connect to that, and so that we can tweet all of your friends every time you do something? And that causes a data exchange between those cloud providers. Not through me, initiated by me, hopefully, but not through me. It's direct across there. And exactly what data is transferring across there and in what direction isn't really clear when you're signing up for any of those services. Okay? But it can get worse. I also happen to use PaperShare. And PaperShare, you know, if I publish a new paper out in PaperShare, I have it tweet all my friends automatically for me. Great, so now that happens over there. What nobody can tell me is, did I now make a way to have a data exchange from PaperShare over to Google? I don't know. Maybe I did, maybe I didn't. So this kind of stuff kind of concerns me. You know, I think we got to get our arms around this stuff pretty soon. So started thinking about, you know, how can we model this stuff and figure it out. And this is sort of, you know, my first thought process on this. This would have been the end of last year, where I'm starting to think about, you know, I got these data sets, I'm going to have multiple of them, and then I got these entities, which are kind of these cloud providers out there, and I'm going to have these sets of rules on there. And it really didn't work for me all that well because of what we just saw on that previous slide there, where we had these other linkages going on there, and I had a hard time modeling that. But I did come up with the idea at this point of calling this the dataverse, right? So I've got this universe associated with this data set and all of the things around it that affect it. So this spring, I actually turned that model around a little bit. So I reversed my visualization here between the rules and the entities, with an idea that if we can do a good job of defining the rules, then these entities we can then assign to the rules and say, okay, you're allowed to do this to the data. Right? And I actually like this a little bit better. And so to fulfill this thing out, I came up with a set of requirements. And there's basically three major areas that we really need to work on to be able to build systems using models like this. So the first one are the data sets themselves. We still have the problem we had 5 years ago. You know, we still need to organize our data somehow. And I'm not sure what the best way is going to be to do that. 5 years ago, I was thinking, you know, we're kind of doing some location-based stuff on our local systems. You know, we have file folders and areas of the registries that are kind of a little bit of this organization, but it's really weak. You know, as soon as you put in an organization in there, you kind of violate the rule and start throwing other stuff in there accidentally because you do a file save and it gets put to the wrong place, and we do things like that. So that wasn't so good. So I was really highlighting the bottom two items there of either using self-describing data like XML or tagging. So we can have files and have a tagging mechanism to identify the kind of data this is. And that could be a way that we could organize it so that tools could deal with this. Today, particularly as I'm thinking about cloud, the cloud immediately is almost kind of a location bounding for this data, I have certain types of data in the different cloud providers, and then by doing that, I'm kind of doing a form of location bundling. But I think as that whole cloud use improves and increases, that's probably going to break down just as it did on my hard drive. So that's probably not going to work in the long run. And probably still something like tagging is ultimately going to be the direction that we have to go. But we still need to figure out what those categories are. How do we need to organize the data in a way that we can deal with it in the future? So there's still work to be done there. The second thing is the entities. And there's two things to talk about on the entities. There's people and there's software and applications. Okay, so for people, we do a great job today of taking a look at user identity. And I think we've done a lot of really good things there. But there's one big problem that I see with identity, which is that people have multiple user identities. I have a tmangan@tmersion.com identity, and I have a Gmail identity. And they're different identities. And so if I had some data that I wanted to share, let's say with all of my fellow CTPs, except those that are direct competitors of my company, I have a really hard time doing that today, because if I tried to do that up on a share somewhere and I was able to describe that type of authorization in that fashion, I can very easily say, let me pick on somebody. Sean Bass, he's a competitor. So anybody from his company is not allowed. But if they're one of the CTPs in the list, then they're allowed. That's great, as long as he happened to come in using the Sean Bass ID. But if he happened to use his other ID as a way to get there, I wouldn't know that those two people are linked. So we need to solve that problem somehow. We need to have individual identity for people and not have these multiple identities. So the second thing is the software and the application. So by this I'm thinking, Facebook, for example, is both an application and a company. We don't have an organized way to identify these things. And so as we want to start building up the Dataverse and the rule sets and these linkages between them, we're going to need a way to uniquely identify these things. And so there's a lot of work to be done in that area. So that was the second one. The third one are the rules themselves. Now when I talk about rules, I'm thinking very, very simple rules. We need a set of rules that are unambiguous, I'm thinking short, cryptic, okay? The rule might be, you are allowed to open and view this file. The rule might be, you can modify this file. The rule might be, you could share this file with other people, okay? Very simple, easy to understand rules. And if we could get one really good set of rules defined for all of the Dataverses, right, then we'd be well on to solving this problem. Okay? And that's something that I'm looking forward that I think we really need to work on. Of all of the three things I just talked about, that's the important one. So once we get these three parts together, right, we organize our data sets, we define the who and the whats that are going to do things with the data, and then we've got a good set of rules that we can then apply then we can start actually building up our data sets, our Dataverses in that fashion. And that's all in good, but somebody's got to do all this, right? So, any volunteers? No. How about me? Good question. I have the answer to that right here. Okay, not going to be me. Thank you. A dozen years ago, I switched from being I'd spent a long time in the communications industry, and I switched back kind of into this systems space. In the communications industry, we had a really rich history of groups to do this kind of work. Okay, you have groups like the IETF and the ISO, and all sorts of consortiums of vendors and users typically that would come together to solve a problem and basically define the standards or the interoperability of how things are supposed to work together. And in our space, we really don't have that kind of thing. You know? We really need something like that. The closest thing that I see out there is really kind of the open source movement, but that's really more about developing software. So I don't think that's quite the right model, but that might be the model that we kind of have to borrow to make something like this happen. But we need a group. You know, it can't be dominated by just the vendors, because what we're seeing right now in this space with the vendors is we are getting some consortiums together to define some of this stuff, but it's really kind of a proprietary approach. It's like, okay, everybody that hates VMware jumps in this group, and we're going to define standards to do cloud, yay! You know, and then they create their own group, right? And what we need is we need a single answer. So I don't know how we're going to get there, but we really need to make that happen. And we need a good set of the groups listed on the left-hand side here to be able to do this. Don't necessarily need them all, but their interests have to be carried out as part of the group charter, even if they don't actively participate. Okay. So I made this statement to Steve a number of months back that, ultimately, if we were able to do all of this stuff, I don't really care anymore where my data sits. And that's the model I'm really trying to get towards, is I shouldn't have to worry about where all of this data is. It should be organized, it should be handled properly with the rules that I put in place, and then once I do that, I don't really care. Is it here on my machine? Is it over there? We pretty much have ubiquitous access, and the location of data really starts to become unimportant, and we can think in terms of data virtualization if we want to use the V word, right? We could have yet another a virtualization out there. And that's really what I'm looking forward to. I think we can eventually get there. I think this is a really, really long-term vision to be able to do that. But I'm really kind of hoping that eventually we lead down that path. So that's my 20 minutes. Any questions? Yeah. Or comments? Right.
It has to be so that you are unable to do that, right? So can you speak to that? What would that mean? The file system like you're currently integrated, because we have administrators.
We need a better answer than the one I'm going to give, right? But obviously, if we thought about just basically encrypting every piece of that data with a unique key, and then had the mechanisms to make that data available to people itself secure so that someone couldn't go around that access, right? Then that might be a way to do that. I think we need a better way to do that. But yeah, that's an interesting problem.
In an encryption layer, then theoretically that's secure, it helps the trusted party, right?
Yeah. That's kind of what I'm thinking. Any other comments or questions? Okay, well, let me get the next guys up on stage. So next up is Michael Burke. There you go. Oh, I need to.
I'm loading a virus on your machine right now.
Okay, no problem. Yeah, I see. Installing driver software. Thank you very much.
Is that what was creating the noise before? Probably. I bet you it was. All right. Everybody hear me? Loud and clear? All right, so this is this is my third cup of coffee, and I watched 2 videos from Sean Bass. So hopefully I can talk as fast as I need to get through this content in the time frame that I'm going to. So performance monitoring in Hyper-V. My name is Mike Burke. I'm a principal consultant at VDX. We do a lot of work in the virtualization space with clients, and obviously performance monitoring is near and dear to everybody's heart in terms of being able to do fun things. So why monitor? You know, why is this important for us to do? A couple things. One, it's the ultimate troubleshooting tool to find out why is a particular workload sucking or not working as well as it should be, but also any kind of long-term any scalability or projections for scaling, all are going to be based upon what kind of metrics I can gather and what's important about those metrics to be able to look at those. So question we get all the time is, well, where do I monitor? Do I monitor in the guest? Do I monitor from the parent or the host, the hypervisor itself? And really, it depends upon what it is that you're trying to capture out of that. You can get a lot of good information from both places. I can get great information out of the parent partition, and up here you see kind of what an architecture of Hyper-V looks like. You have the root partition or the parent, and then I have a bunch of virtual machines that would be running on this. And there's an interesting relationship that occurs between these. Anybody done, who's worked with Hyper-V here? Right? So anybody fire up Task Manager on a Hyper-V server and look at the performance of CPU? What does it look like? 0. That's because I have 24 CPUs in the box, I have 82 virtual machines running on the machine, and Task Manager is telling me that nothing is happening. That's because I am viewing the process capabilities from the perspective of this operating system, which is not really using anything on the CPUs. So that's why things like Task Manager and certain counters don't give you much visibility into what's going on under the covers, but there are counters that are baked in to be able to give you the kind of information. So the question of, is it guest or parent? Most of the good information comes out of the parent in terms of understanding what's happening in the workload. And most of the counters that are in there per virtual machine can be gathered on a VM by VM basis and archived. And then what you look at inside the virtual machine is more around things like rate counters, application counters, et cetera. Anything that uses utilization is definitely skewed in terms of looking at what's going on in there. So what matters? I like to look at performance or any kind of monitoring or any kind of thing as 2 diverse or distinct areas, compute and I/O. These are 2 totally different things. My compute resources are things that are going to be more utilization-based, are going to be more consumption-based than I/O, which is all distinctly consumption-based. I'm all talking about rates and IOPS and how much data or information I'm pushing over wires or down to disks, et cetera. So utilization versus rate. These are important things to think about or to understand when you're looking at monitoring anything from a hypervisor perspective, because utilizations are easily skewed when you're looking at things from the parent partition, you're looking at the counters. Even when you're looking at utilization rates inside of a virtual machine, you're looking at a perspective of what's been granted to that virtual machine. And when I'm looking at things from the hypervisor side, I may not be seeing the full picture because there's things that are happening. There's overheads associated with running virtual machines. There's things that are happening in the root partition. There's individual virtual machines. There's idle spin counters. There's a lot of things that are happening that rates are very finite. How much data am I pushing over the network? How many read IOPS are occurring? Those are things that are very finite and defined, regardless of whether it's in a VM or it's on a host and where I look at the picture for it. So I'm going to rip through a bunch of counters and capabilities that are in here. These are all counters that are exposed through perfmon, and then obviously because they're exposed through perfmon, any tool that you use to pick up these counters in a centralized manner like SCOM, HPOV, any of these other tools, you can obviously consume and use these. So some things to look at overall health from a hypervisor perspective. And when I have something in the blue bullet there, hypervisor, that means that's the name of the counter itself. And then the sub-statistics that you would pull out of that are these areas like partitions, number of virtual machines that are present. Why would you care about that? The number of VMs. Very good for trending analysis. Be able to look at the number of running virtual machines over a period of time. Has it increased or decreased? And how many systems are sitting on a per system. Logical processors versus virtual processors. A logical CPU in Hyper-V or in any hypervisor is how many CPUs does the host address and see in the box versus the virtual processors that are assigned. We all know that virtual processing is a one-to-many scenario. So I have one logical processor that's currently being scheduled with 4 or 8 virtual CPUs. Knowing these relationships or being able to track or counter these relationships can provide a lot of information. For instance, today everything is running fine, and I'm running a 6-to-1 ratio of virtual CPUs to physicals. So a year from now, I'm looking at this going, why is the performance so much farther down? I see I'm running 18-to-1 or I'm running 16-to-1 on virtual CPUs versus logical CPUs. These kind of counters can provide some insight into the overall health. And then total pages is a counter that will give you some insight into what the memory overhead is. So every virtual machine that you run on a Hyper-V server is going to eat 32 megs of RAM for the first gig, and then another 8 megs of RAM for every additional gigabyte after that. That memory disappears from the system and is different than the 1, 2, 8 gigs that you give a virtual machine. If you want to know exactly how much overhead is going on in the box, the memory pages will give you some indication on that. And then from a Hyper-V virtual machine perspective, a critical or okay just looks at the overall health. If you have a system that's in a critical state or it's okay, it can give you some idea on that. That's just reading the heartbeat information that's coming out of the tools to see what's going on. So for CPU monitoring, Hyper-V logical processor. This is the hypervisor logical processor from the Hyper-V perspective. You've got a bunch of counters, and these are all kind of cumulative for one another. So the percent guest time versus hypervisor host runtime is the difference between how much CPU is being allocated to guests versus the host itself. And this is running the parent, which is line item number 2, or guest runtime, which is every individual virtual machine. And these are hosts, so you want to look at totals here. Idle runtime is time that's spent in the idle loop, which is that in Task Manager, that mystery process that seems to consume all the utilization, which really is not any utilization. And then the total runtime. So total runtime would be the accumulation of all of these individual pieces here. If you look at totals, you want to look at totals on these above ones, but if I have 24 CPUs in a box or 16 CPUs in a box, I want to watch LP0 because LP0 is where I/O interrupts get hit on the server when you have, hey, I got to process something on a SCSI controller or something on an I/O controller. If you see relatively low or medium to low utilization, but I have a high utilization on LP0, it could indicate that I've got an I/O bottleneck because there's a lot of interrupts being hit. And then in that case, I would want to look at what my interrupts counters are to discover what that's going on as. System processor queue length, 0 or 1 is optional. This is a typical Windows counter that you would see. I don't want this to be any higher than 1, if at all. 2, 3, 12 is really bad. That means I'm severely oversubscribed. So that was from the host perspective. Now from the guest perspective, in terms of what you would look at for monitoring, virtual Hyper-V hypervisor virtual processor. This is looking at the virtual CPU, but from the host's perspective. I can look at the guest runtime, and I can look at this either cumulative total or each individual virtual machine. So every time a virtual machine is running, it will indicate the name of that virtual machine next to that counter. And again, I can be collecting this information. And that's how much time is spent processing guest time. And then there's also a hypervisor time that's associated with that, also per VM instance. Why would the hypervisor time really matter for that? Generally, this is going to be a pretty low counter, but if you see something creeping up towards 20%, maybe even a little bit more, it's a good indication that you may not have the integration services loaded in that VM, and it's actually running in legacy mode. You get a severe penalty on that, so you always want to make sure that that's running. These days, you'll probably only encounter that on 2003 systems or XP systems. Windows 7, 2008 R2 and above, including Vista, all have integration services loaded natively, so you probably wouldn't see anything specific around that. CPU wait time per dispatch per virtual machine means in the guest, I'm seeing that the CPU is waiting for scheduling on the physical CPUs in the box. This is my bottleneck of there's too many virtual processors to physical processor ratios. I'm sitting in a wait queue for my stuff to get scheduled on the physical CPU. If this counter starts to go up any higher than 0 or any higher than 1, there could be an indication, in nanoseconds, you could be an indication that you're starting to stack up workload on the box. And hypervisor root virtual processor, they have the exact same counters as a Hyper-V hypervisor virtual processor per VM, but the root virtual processor is specific to that parent partition, that host partition. This is the utilization statistics for this specific place. What would high CPU utilization on the root processor indicate? Any ideas? Could be a rogue process or an agent or something that's starting to chew up a lot of time in the CPU that's running in that host. Maybe I have an agent, somebody's decided they're going to play games on the host operating system, whatever it is. Memory. So memory is a finite area of resource. There's only so much I can fit into the bucket. When I'm out of memory, I'm out of space. So from a memory perspective, available bytes is going to be a counter that will tell me exactly how much room I have left. That's all up. Available bytes will show you how much is there. So whether it's memory allocated for the hypervisor, parent partition, virtual machines, VM overhead, all that stuff comes out, and what I'm left with is available bytes. So that's how much room in the bucket is left. The dynamic memory load balancer is going to give you statistics around how healthy or how well performing dynamic memory is working. So the available memory for dynamic memory would be different than if you took a cumulative total of how much memory has been allocated to a virtual machine. One of the things that dynamic memory does is it has a lot of magic that happens underneath the covers to try and recover and pull back memory from systems that aren't required. So even though I'm in a VM and I look in Task Manager and it tells me I have 2 gigs of RAM, I may only have 600 megs of physical RAM allocated in Silicon on the box. The other 1,400 megabytes is actually in balloon space on the hypervisor and is being allocated to other systems. So the amount of pressure that's being put on a system to pull that memory back because it's no longer needed is something that is a counter that you'll see in there. If you see high pressure but low utilization on virtual machines, it's a good indication that the virtual machine probably has more memory configured for it than it really needs anyway. Hyper-V dynamic memory per virtual machine. So guessed visible physical memory is, again, how much memory is allocated to that. When a virtual machine, even with dynamic memory, gets more RAM by the hypervisor, that never shrinks. So I'm a virtual machine, I boot up, I have a gig of RAM, I have a gigabyte of memory. That's what I see. I'm running my processors and I need 1.2 gigabytes of memory, and Hyper-V grants that to me. I now see 1.2 gigabytes of memory. If I later only require 700 megabytes to do what I need, I never go backwards. I always see that same amount of memory until I reboot. Because Windows doesn't like to see memory get pulled away from it. It's okay to see memory suddenly get added to it. So these counters, when you see guessed physical memory increasing, but then you also see the pressures increasing. That means for some reason the memory went up on the box but didn't have to scale back. If the memory utilization is overall high and stays that way, and then I see CPU starting to creep up, that may be an indication that I'm oversubscribed on the box. And then there's a counter in here, Hyper-V VM VID partition. NUMA nodes are obviously when you have CPU and memory space allocated per CPU. And obviously Hyper-V will do its best to keep a virtual machine contained into the CPUs that it's running on for the memory that it's using. If you look at these counters and you see a lot of remote pages on this counter, that means that virtual machines are having to span across NUMA nodes in order to perform. If there's a performance bottleneck on that system where you suspect that that may be responsible, you can actually turn off NUMA spanning and then see if that improves things. What about pages per second? How come I didn't mention pages per second? Anybody have an idea? Come on. I know Dave & Buster's is only a few, brief minutes away, but pages per second is not an important counter in terms of Hyper-V, generally speaking. Reason why is because virtual machine memory is all non-paged pool. No virtual machine memory is ever swapped out to disk, so there's really not going to be a lot of swapping. In fact, when we create Hyper-V servers, we usually contain our page files down under 4 gigabytes, no matter how much memory is in the box, because the only thing that we'll ever swap out would be parent partition memory space, and only a certain amount of that. So pages per second is not really an important counter to watch, because you won't see much paging ever happening on a Hyper-V server. If you see a lot of paging happening and it's happening in the parent partition, it's probably a good idea that you're either oversubscribed in the memory of the box, which means your available memory bytes will be low anyway. But if it's not, somebody's probably got some rogue agents and things running on there that shouldn't be. Network perspective. The network interface, total bytes per second, packets per second, these are all self-explanatory. These aren't anything different from a Hyper-V perspective. So these are just regular network counters. It's how much information I'm pushing over the wire, how many packets I'm pushing over the wire, what kind of output errors or receive errors I'm seeing. And if I have a queue length on a network card, then obviously I'm starting to stack up I/O operations on the box. Hyper-V virtual switch. These are overall in the virtual switch, so I'll see things like how many transfers, packets per second, and bytes per second across all running virtual machines that are plugged into that virtual switch. These are good counters to trend against, not much that would give you any information for troubleshooting purposes. For storage, physical disk, the current queue length. I have here less than 5 is optimal. I'd probably even say that this would be less than that. Generally speaking, because RAID controllers that are sitting in servers are, most of the I/O is happening into memory, really this should be really low. But there are indications if you were using Windows-based RAID, because I know we all use that for our enterprise servers, these numbers could be higher and actually be healthy into 10 or 12 current disk queue lengths, depending upon the number of disks that are actually in the box. Because if I have an acceptable number of 2 and I have 8 disks in the box, I could have a queue length, a total of 2, because Windows is doing the magic of the RAID and I'm actually able to see that information. But because memory-driven RAID cards are probably going to be faster than writing the information to the disk, that should be sitting pretty low. If I see anything on there, that could indicate a problem. Disk bytes per second, again, that's the amount of information. And then disk transfers per second, that's my IOPS number. And then I can also look at this in terms of individual reads and individual writes to determine the difference between those. So again, these are physical disks. These are not specific to Hyper-V. It's just going to look at the I/O coming in and out of the box. And then logical disk, average reads per second, or average seconds per read and seconds per write. How much time is it taking to be able to complete the operation? I want relatively low numbers here as well. 10 milliseconds or less is healthy. Anything over that is a warning. If I hit in the 25 millisecond range, I'm in serious trouble for performance. Hyper-V, so these are 2 counters that you will see in there, and these are specific to Hyper-V, virtual IDE controller and virtual SCSI device controller. So an interesting thing about Hyper-V, if you don't know about it, is that every virtual machine that you ever build in Hyper-V boots off of an IDE virtual drive. Nothing ever boots off of a SCSI drive. But we have a SCSI controller in every virtual machine to be able to support additional drives for DE, etc. There is a slight difference in the performance of a virtual machine when it first turns on to the point that the integration services load when the operating system comes up. IDE controller will start its life in legacy mode, and then as soon as the services are up and running, I switch over to synthetic mode and I'm starting to run really fast and efficient. I will see some counter activity on virtual IDE controller if I have systems that are running without integration services. Once the integration services are loaded, everything goes through virtual storage device counters. So I should see all my counters for reads, writes, my IOPS for reads and writes all flowing through the virtual storage device counters. If I'm seeing a lot of counters on the top one, that means that I probably don't have the integration services loaded in those virtual machines, and I could have some performance issues there. Big picture monitoring. So 2 things, that have 5? Perfect. Big picture monitoring. So these counters are exposed to perfmon and through WMI, obviously, to do remote monitoring. The statistics that you'll get out of those are going to be very real-time, very frequent counters that you'll see. So looking in perfmon is good for troubleshooting, not really good for long-term trending, because it's a pain to comb through log files and open those things up. So obviously if I have a SCOM or I have an HP OpenView or some other tool, CA, that I'm going to use to comb these statistics in, that's going to be good for long-term trending, but know the difference between them. So if I have a problem and I need to troubleshoot, I'm going to want to be in the perfmon counters or looking at counters real time because I'm seeing much faster results of what's going on. When I'm looking in a SCOM, I'm looking at the law of averages across a period of time. SCOM's going to do a 5-minute catch on those statistics, and I might miss something that's happening very frequently. So I'm going to look at trends, I'm going to see statistics over a period of time, but if I'm trying to troubleshoot something here and now, I want to actually be in the individual counters themselves. Questions? I ran through a whole bunch of stuff there. I apologize if that was too rapid fire. But the good news is this will be up on the BriForum site, so you can go check out what the counters are. Cool. All right. Yes, Tim.
Are you prepared to talk about how Hyper-V R3 changes any of what you talked about?
These are all counters particular to Hyper-V R3, but in terms of the specific counters, there's some changes to dynamic memory counters. There's some changes to the health counters. Not a lot of changes otherwise, except for like remote FX counters that we went through earlier. Those are different. But nothing from the hypervisor perspective that I'm aware of. Yeah, I have seen them top out on that. Not in, when I mentioned it before, I was talking from the perspective of I see utilization around 30, 40%, and that particular CPU is higher, up around 100. That's a problem, but you will see that when your utilization is up like 70% overall in the box, LP0 will be getting hammered because it's responsible for those interrupts. Yeah, that'll be the first one to go out when utilization is just up at the top. Cool. All right, thanks. Next. You want a stick? Clicker doesn't work.
Okay. Okay, perfect. Can everyone hear me okay? Perfect, excellent. So as you can see, I'm dressed a little bit different today. I wanted to kind of shake it up a little bit. I wanted the suit and tie. I see no one here wearing a tie, so I just wanted to kind of be a little bit different because that's kind of the way I operate. So in any event, so my name's Ryan Sobel, and I work for a value-added reseller called Ironbow. And let me click here. I just want to give you a little snapshot of the company and where we're coming from with this use case. So again, I kind of wanted to shake it up a little bit at the BriForum. I wanted to talk about a real live use case for VDI, right? So this has actually really happened, and it was actually a really good use case on how we went about it. This is with a federal agency, that is. At Ironbow, we are about 95% federal, on the federal side. So any federal contractors here are working on the federal side? No? See, that's why I wanted to change it up and shake it up a little bit. So anyway, but you can substitute the federal agency for commercial or private entity. It's really kind of, you can really kind of work it both ways. So trivia question, right? So can anyone answer this trivia question real quick? No? Yes, no, maybe? Yes, exactly. So really quick, so the top three really, security. I mean, I'm not really telling you anything that you don't already know. So secure virtual desktops, right? Business continuity, just a fancy word for saying, hey, listen, I want to be up all the time, right? You know, why am I going to use VDI? Well, I don't want to be down, right? I don't want my classic laptop or desktop, blue screen of death, and then I'm down, and I have no way to get to my, to my desktop and do my work. Operational efficiencies. So this is a good one too as well. So operational efficiency is, again, just a fancy word for saying, hey, listen, I want to be effective. If I'm working on, if I have access to my virtual desktop, whether I'm at home or I'm at work, or let's say I'm on the road, or even, my smartphone or tablet, I could be more efficient. And it's just a proven fact that you can be, because you can work on your own device at your own time and your own leisure. So let's kind of, I'm going to paint the picture here of the overall presentation. So, and keep this in mind as I speak. So what happened was there was a disaster. And again, you can substitute federal agency for commercial or private. It doesn't really matter at this point. So there was a disaster that happened. Came ripping through the region. The region was basically, really torn into shreds. And no, it's not a tornado. I just put that up there, by the way. So what happened was, the federal agency came in. They had, tens, hundreds, even thousands of workers. Yes, thousands of workers, going into the region. Some staying there for about a day or two, collecting their data, doing whatever they have to do. Some staying there for a week, 2 weeks, 3 weeks, months, right, on end. Actually, we still have people going into the region and doing what they have to do, collecting their data, sending it to a central repository, boom, and then out to one of their, their regional data centers. So we still have folks doing that. So the challenge, and we'll go over that, but the story was, all right, listen, there's, hundreds, thousands of federal workers coming into the region. They couldn't roll out physical laptops or hand them out that fast. It's just they couldn't do it. It happened, the disaster happened too fast. They had to be there ASAP, and they just didn't have that many laptops for that matter. So then, what happened? Well, the worker went to Staples. They went to Best Buy. They went to whatever store was selling physical laptops, right, to grab any laptop they can. And they actually sold out in that region. There was no laptops at any stores. Best Buy, your Staples office, there was none. That's it. So, this is a no-no, right, especially on the federal side. But again, it could be on the commercial or private side as well. So you can't just take a laptop from Best Buy, standard stock image, right, and then just, remote back in and get to a federal agency's network. No. Or on a private side or commercial side, for that matter. Just not going to happen, right? So how do we counter this, right? So what are we going to do to counter that? So that was basically one issue. That was the main issue. So there just wasn't enough physical laptops. So how can we roll out something fast, safe, and secure? So the other issue was, overall, the use case was taking all that data that someone was doing, processing out there, and putting it into a central repository, regionally that is, and then send it off to one of their regional, national data centers. So, as well as standing up, that is hardwired, that is, you can't really call them regional command centers, really, in warehouses, where they actually, have hundreds of workers sitting in an old warehouse, hardwired in, they got their network connectivity. Keep in mind, we also had folks on, little remote command centers away from the warehouses in unknown places. Can't really say the name. If I tell you, I'd have to kill you. So anyway, so that's, but in any event, so that's sort of, keep that in mind. So when I talk, so that's kind of the scenario, right? Disaster came in, how do we get this going, right? And it's a real life use case scenario. So the objective, so what happens when a disaster strikes, right? So again, we want to roll out desktops fast, safe, and secure. Main objective. I don't want to go to Best Buy and use a physical laptop, right? It's not safe, it's not secure, it's not up to the standards of that agency or commercial or entity or private entity. So OS compliancy with the agency. They have strict rules, right? They have golden images, which I'm sure everyone's aware of, right? A master template of what the image should look like. So we want to adhere to that compliancy as well. And then, of course, providing all the federal workers with, all the immediate flexibility and access to their desktops any place, anytime. I mean, these guys can going to mobile command centers. They could be in the warehouses. They could be in the hotel. They could be at home, right? So we want to give them access. So a couple others, the COOP, comply with security requirements that they have. Again, stringent security requirements on not only accessing the network, what you can do on there, but as well as the OS. Reduce the cost and complexity of managing this whole situation. So this was kind of a fiasco, right? Think about thousands of workers, and it literally was thousands, coming into one region at one time. How do you manage all that, right? How do you manage all these people grabbing desktops here and there, or laptops, and physical that is? How do you manage it? You can't. And that's what really was the use case. And of course, streamline all the IT operations. So today's client challenges, I mean, this is actually, it's kind of a nice slide. So we all know some of today's client challenges. I mean, it's tough. They're not flexible. It's hard to manage. Obviously, security, right? That's a big concern. Availability. If my laptop or desktop, something's wrong with it, it goes out. I need an IT person to come on over. Maybe they remote in, maybe they don't. Maybe they have to ship me out a laptop, right? And I got to ship mine back, or maybe I have to wait a week, 2 weeks for do whatever they have to do, provision an OS and load some apps and yada, yada, yada. So you kind of get, today's, client challenges. It's tough, right? So that's where we look at some of the real world use case challenges that this particular one had. So the disaster strikes, so we have infrastructure upgrades, compute, storage, and network, right? Those are the three main things that we really looked at. So how do we address that? How do we address compute, storage, and network, right? And it was a short window that we really had. The disaster struck, we came in there as a team, we worked with their guys, we came up with a game plan or a blueprint and architecture, and we kind of rolled it out. Short window, no, it didn't happen in we didn't roll out hundreds and thousands of virtual desktops in a day or two or weeks. I mean, it took about a month or two. So that's what we call on the federal side a short window. So that may be long on the commercial side, but on the federal side, that's pretty damn short. So how do we do that, right? How do we secure the images? That was a challenge. I mean, fast and efficient deployment. That was another challenge that they had. And they had a lot of questions. I mean, centralized storage and data. So how do we take a big SAN, put it in a warehouse, and centralize all that data? Because when this thing, because there was some litigation that came up with this too. So this actually went to trial on some degree. So when this came back and the lawyers wanted to look at keywords in different emails, right? So the folks who were on the field doing their thing, sending their emails and data back to the centralized storage, right? We need to put something in process and play, to look at that data and sift through, thousands of emails to find that one keyword that they were looking for. So end user performance, right? That's a big one. We all know in the VDI space, right? That's just that's where it's at, right? It's all about you guys, right? The end users. So if it's not there, you're not going to use it, right? So we, had a lot of going back and forth and looking at performance. How do we guarantee performance? How do you guarantee performance with a federal worker, private, commercial, working in a tent somewhere over a 3G network? You can't, right? It's 3G. We all know that. But there were some ways that we did look at to help kind of manage that process. So management of desktops, right? How do we look at managing all the desktops? That was a challenge, right? You couldn't do it on the physical side, but on the VDI side or on the virtual side, you could to some degree, absolutely. So do we use zero clients, mobile clients, thin clients, thick clients? Do we use zero clients with an embedded Terra chip in there from Teradici? Do we just use something that's more universal? That can maybe look at Citrix or VM or use any protocol for that matter. PC over IP, HDX, whatever it may be. So some of the other challenges, now this is kind of higher up, right? So this is looking at, some of the C-level, employees on that level. It wasn't really C-level. We don't call them C-level. They had other titles. I can't give away the titles because it's going to give away the agency. So in any event, C-level. So this came up, and this is going to happen every day. So when you look at VDI, right, all your C-level employees, I mean, this is some, pretty typical, questions, right? They don't understand how to go about it, right? what should they do? How did you size or create optimal user experience, right? How do you do that? So, what's the best way to ensure all data and users are migrated seamlessly, right? How are we going to go about this? They just were unsure. So we had to come up with a plan and how to counteract that and how to do that. Kind of put their mind at ease, quickly, that is. The decision makers were really hesitant, right? So that's something that I'm sure everyone have seen out there. So with VDI, everyone's still sort of dipping their toe in the water. It's not like server virtualization where we know it's almost a commodity at this point. I hate to use that word, but it's almost there. Everyone's pretty much doing it to some degree, or they haven't tested and dev or are thinking about it, right? It's there. Everyone's sort of doing it. VDI, they're still kind of dipping their toes in. They're getting wet, and hopefully one day it will be there. So they were skeptical about end-user performance, video, and the performance there. So we worked with Teradici. Obviously, who we're using, obviously, for VDI. So we worked with Teradici, and we came up with some good ways to ensure that the performance was there. Patching and patching as well, updating and patching. So that's time-consuming. So how do we counteract that, right? Well, there's certain things and tools that we put into play, that can help with the patching and updating. So VDI, right? That brings us to VDI. So keep in mind the story now with the disaster, right? The disaster strikes. So we have a limited amount of time, according to the government, which is maybe a long time on the commercial side, but a limited amount of time to put something in place. And they wanted this plan. The most important thing is to understand that they wanted this plan to really serve as the blueprint for any type of future disasters, right? They don't want to have to go about trying to reinvent the wheel again. So let's come up with a plan to put in play when there is a disaster and use it on any different occasions come up down the road. So why VDI, kind of talked about the security, the data privacy. That's actually really important, especially on the federal side. Bringing all that data in, they don't want it leaked anywhere. They don't want, storing a copy on your C drive or whatever it may be. So they want it all sitting back on in the warehouse, right, on the storage there. So a better service delivery model. Again, going to Best Buy and buying laptops, it's not going to work, right? It's not going to fly anywhere. I don't care if you're federal, commercial, private. It's not going to work. Not on this side. So centralized management. So how do we manage, right? How do you manage and again, this goes back to why VDI. How do you manage all these endpoints out there? We had a ton of different, actually we had thousands of Zero clients in a warehouse. How do you manage all that, right? So, and that was one way that we came up with, another way using Teradici's management console. Pretty easy, very easy to use, right? You fire that up, it comes in an OVF, import it in your ESXi environment, and there you go. It's going to automatically discover some of the Terachips out there. And then you can create user profiles behind that, push them out to all the Zero clients. That's what we did to help manage that. Because there was different groups. There were some workers that came in, say, worker A that had maybe 50 users attached to it or 100 users, and they needed a certain type of profile. So we did that in the management console, and we pushed it out over the network. Maybe user B had a different profile, which we also configured on the management console and pushed out. So this is kind of a classic slide. So kind of getting down to it, VDI, right? So we're using VDI in the disaster situation, right? But really the key behind it is the end users, right? It's you guys, right? It's all about the end users. And when you look at any VDI environment, I don't care if it's in a disaster or just a non-intrusive environment where you're just kind of trying to roll out VDI, whatever it is, Citrix, VMware, whatever your choices for software or in protocols. It's all about the end users. So you have to understand the real world apps that your end users are using that right now, and that could be from a first stage task-oriented user where maybe 9 to 5 user. Surfing around, maybe using Office, Word, PowerPoint, pretty light on the load, all the way up to maybe a performance user. We've had users that were looking at high-end graphics, right, or high-end imagery, maybe geospatial imagery, right? So something to that effect. So you have to understand the users. If you can't break down and look at your users and say, okay, I have this type of users, I have this type of user, and that type of user, you're not going to have a successful rollout. So that's something that we really, really had to strive for and understand in that short amount of time, what the different users were doing. We actually even had to go back and cut some apps out of the solution, which were actually not needed at this time of disaster, that is, to fit them in. Because there's no way that we can, in that short amount of time, at least on the government side, that is, to get all those apps in. They just wouldn't work. So we needed the basic core apps that we can get to collect that data, do what you got to do, and then file it back in the central repository on the SAN. So understanding end users, that's really key. And that just goes without saying for VDI, right? Understand your end users, what they're doing. Categorize them. It doesn't have to be like this, but you can categorize them, maybe user A, B, C, D, and what they're doing, which is really understanding the apps. So positive business impact. So on the business side of the house, and there's always a business case for this, right? So this really served as a future deployment. So you could have a blueprint to roll out, VDI in case of another disaster, or maybe it's not even a disaster, right? Maybe they want to roll out VDI for 100 users in this type of division that they have. Okay, great. Well, we have something in place now. Let's use that as a blueprint to roll out, another type of VDI environment. Desktop provisioning, so that was pretty key. So we all know rolling out a physical desktop, well, especially on the government side, it doesn't take, an hour, 2 hours, probably on the commercial side too. It takes a long time. I mean, they got so many different, security requirements to put in place, so many different angles to hit, different OSs, different golden master images, and then of course, looking at, even stigging boxes. So we took that down from 3 to 4 hours to 20 minutes or less. So great use case. Free up IT staff, so classic, right? You'll see that in any type of, and everyone always touts that, hey, implement VDI, it's going to free you up to do this type of mission critical process. Sure, it will. It'll help out. Is it the end all, to free up IT staff? No, but it's going to help free up some time. It definitely will. Work anywhere on any device. So that was pretty key. In this, and you have to excuse me if I'm talking fast, I just kind of want to get through here and maybe get some questions. But so, any device, anywhere, so that's pretty powerful, right? Mobility. So, as we're sort of, consumers driving mobility these days, it's not, our IT staff anymore. It's, well, at least on the government side, it's, it's us, it's the consumers. So, as we drive that, we want to work on any device, on any time, anywhere. So, for example, on the federal side or on the DoD side, you have a colonel that comes in. He brings an iPad in, even though it's not allowed on the network. Oh, what? He wants to use it on the network? Well, wait a second. IT's going to back off and say, hello, that's not allowed on the network. But look at my rank. Okay, now it's on the network, and they have to support it. So, I mean, you can translate that same thing on the commercial side or the private side. You have a C-level employee that comes in, brings whatever type of device. It's not typically allowed. Oh, yeah, but I am, I'm the C-level employee, right? You're going to make it happen. So they'll make it happen. So bring anywhere, any device at any time. So that was pretty key. So we had a lot of federal employees that came down. They had their, the VDI image in, say, the warehouse, working off of a Zero client. They went out into the field to collect data. They brought their, tablet, right? They brought their, laptop, right? And then they used their connection back into the data center to fire up their VDI session. So pretty key on that. So control and lock down the desktop and still allowing personalization. Yeah, I mean, that's big too, right? Persona. If you don't have the right persona in play and pulling down that persona, they're not going to get that, desktop that they all, kind of know and love with the picture of their dog on it or whatever it may be. So I talked about a lot of this before. We did have great success with it, but with any success always comes like some road bumps, right? There's not one product or implementation that you can say that, hey, it went 100% smooth. There's always something in there, whether it be small or large. So yeah, we did have some road bumps, but we got over those. We worked together to roll out this blueprint for a VDI environment, which they're now using, and they're still using today. Granted, we'll make some modifications to it, but they're still using it today. So structured project plan in place. So one thing that they were really big on was having, the PMs and having a really good methodology in place, right, as we go about, this 2-month implementation, and to collect that data, to store it, and send it off to regional data centers. So we had a really good methodology, and that's kind of key, right, to any successful deployment is have that methodology in place. If you're structured like that and not just kind of flying by the seat of your pants, it's going to work out well. So we sped up the analysis and troubleshooting. That was kind of big. The admins really appreciated that. The end users were extremely happy. Of course, we got some folks that were, there's nothing you could do about that, but they're always kind of, complaining here and there. But most of them, I would say probably about 90 to 95% were actually really happy, especially the ones that came down for a week or a month on end. Getting to 5 minutes, okay. So that actually worked out well. So I'm going to kind of roll through some of the successes here. We secured the desktop in the data center, right? That goes back to the security. That's the whole VDI type story. We put in some workflow and automation as someone can request a desktop. So federal worker came down and said, hey, I need this type of desktop. It went through a workflow and automation process. Yes. Signed, delivered. Now they can log in. So let's go back. Let's look at some tips and tricks. So, and if you sat in the other session for 50 VMware tips and tricks, I think it was, you heard him talk about PC over IP as the protocol, right? So it's you got to treat it as a real-time protocol. If I give it this much bandwidth, it's going to take this much bandwidth, right? But it's very adaptive. If I give it this much, it's going to take that much. That's it. And it'll adapt to it with build-to-lossless technology, right? So other tips and tricks, use NAND flash. So a lot of iPhones out there, right? What do you think's in there? It's NAND flash. Use that. Use that to your advantage, right, to build up the IOPS. Because, again, it's all about you guys on the VDI side, right? It's making you guys happy. And if you don't have the proper amount of IOPS to power or run your VM, well, you're not going to have a successful deployment. And then you're going to get everyone revolting. So use some NAND flash, whatever that might be on that side. Don't forget the network. That's big. And manage hardware bottlenecks, right? So a lot of people roll out VDI but don't even pay attention to the network. So that's something that you actually have to look at. So I suggest looking at the network, doing some sort of a network assessment on it, and making sure it's up to standards and up to par. Management tools, real big. So how do you manage all your desktops, right? How do you know that they're performing within the farm? Maybe they're not. So there's a lot of third-party tools out there that can help with that. Say this desktop is suffering. Well, how do we know that is suffering? Where is it suffering? So let's take a look at some management tools. Persona management. So that's big too. Obviously on the VDI side, it's all about you guys. So look at the persona management, and I'm getting the high sign to wrap that up. So persona management, take that down. Real quick, one other type here is the PC over IP card. It's an Apex 2800 card by Teradici. So take a look at that card. So what that does is it offloads the graphics onto that card, so it allows you more desktops onto that maxed out host, up to another 64 desktops per host. So that's something that can come in big time as you roll out VDI. So the one takeaway I want you real quick, I know I'm standing in the way between you guys and Dave & Buster's, but listen, VDI, 70% business, understanding the business side of the house. It's not rolling out a desktop. I can roll out a desktop technically, and it'll work, right? So if you can understand the business side of the house, okay, and translate how you roll out physical desktops to the virtual side, you'll be successful. And that's kind of what this whole disaster was. We understood from the business side how they rolled out physical desktops. Yes, we changed it slightly, but then we were successful in rolling them out on the virtual side. The technical side, that just came, right? Obviously, that'll happen. So if there's one thing that I want you guys to take away is look at the business side, understand the business side, translate that to the virtual side, and you'll be successful on that. So, and here's some replays. Any questions, comments? Yes, sir. Yeah, so, yep. Yeah, so good question. So in the warehouses that we had, yes, it was, because we had network connectivity, we had, physical, hard wires, that is. So yes, there was. We did have command centers scattered through the region, But yes, it was hosted at. So, either in where, well, either or. They could be in the warehouse. They could be somewhere in the region at a remote command center. They could be at a hotel. Just kind of depends. I mean, but they were all over the place. I'm sorry? Yeah, so yeah, that's a good question. So after we got that in place, can I use the Best Buy laptop? They could, but we still had to roll out, there were some security requirements in play. So, but yes, we can, they could. So thank you.